Good morning. My name is Andrea, and I am a team lead here on the FME desktop support team, and looking forward to showing you what you can do with BIM today.
Nice. Thanks, Dale.
Hi, I'm Dale Lutz. I'm one of the two co-founders of Safe Software and excited to show you what the results of 20-some years of working hard on all this stuff has led us to.
So awesome. Dave, with your whimsical background.
Yeah, my name is Dave Campanis. I'm with the Strategic Experts team here at SAFE. My focus is mainly BIM and coordinate systems and funky geometry.
Awesome. And then Dean.
Yeah, I'm also on the same team as Dave, and Strategic or Application Experts, and I have focus areas around open standards, things like OGC, XML, GML, that sort of thing.
Nice. Dean, I know you also wrote or co-wrote a couple really great BIM articles. If you want to share those out in the chat with the audience, I'm sure they'd love to see that too. We also have Jovita online to help answer questions, so please keep Dean and Jovita busy. And with that, I'm going to turn off my camera and you guys can take it away.
Okay, well, thanks everyone for tuning in this morning. This is part 2 of our BIM webinar series, and as we hinted in the pre-webinar chat, we are going to go fairly deep, fairly quickly here today to show you some of the ins and outs of how you can really wring the most value out of your BIM data with FME. So we really would recommend that you watch the prerequisite webinar prior to this. If you are settled down and ready to watch us today, of course, you're welcome to stay. But I would, if you hadn't seen another one, I would definitely recommend giving it a look. The archive is up on safe.com webinars, and it's pretty easy to find. And I think Stephanie will have this webinar up by tomorrow, end of day for sure, if you want to watch them in order. But sometimes it's fun to watch things out of order. And if you know your way around FME, I'm sure you'll find what we're about to show today interesting as well. So yeah, we're going to go fairly fast. As Dave has said, we're hoisting the nerd flag today, but our webinars are recorded so you can watch them again. And don't hesitate to ask us questions in the chat. We've got Dean and Jovita there, and of course the presenters will be snooping in there as well when we're not talking. So and actually Stephanie's there to guide us along the way too. So don't be afraid to chat. Unfortunately, as Stephanie said, you can't see everybody else's questions, but we will at the end do a summary, provided that the webinar gods don't cut us off exactly on the hour as they did last time, and we're still recovering from that. So in terms of the agenda today, we're going to have a pretty light intro, and then we're going to get into a set of different scenarios, which you can see there, that we'll walk you through in a lot more detail. And it should be quite interesting. And lastly, we'll finish up with links to a set of resources that you can use to dig in further. So lots of our examples are going to involve Revit today. That's where we have spent a lot of effort over the last considerable time. Probably one of the most complex, big developments we've done at SAFE. And just by way of super fast intro, we exist to move data from where it is to where you need it to be. We want you and your organization to maximize the value of all your data. And over the years, our journey from CAD to GIS to raster to point clouds has led us finally today to BIM. And one of the common comments we hear from customers is that they do all this great, amazing modeling inside of their BIM systems, and all they do with it is produce 2D drawings. And that's a shame. And so we want to give you tools so you can do more than just produce a 2D drawing for a site build. We do have a product called FME. That is what we're going to be using to do all this work, and that's what we've been working on at SAFE for it's like 27 years coming up right away. So I am getting old. But FME consists of a few pieces. One is this workbench, which the screenshot that Stephanie shows there shows you. It is shown on a Mac. I'm using a Mac this morning, but FME actually runs great on Windows as well as Linux. And then we have a server version that you can use as well to install on premises, and lastly a cloud version that you can pay by the hour for. And I think with that, I'm going to be so bold as to go to a flash demo. So as is my habit, I have prepped something a little bit interesting. We in this household right now, we're building a barn actually. I'm a farm boy to begin with, and I'm excited to have a barn which will actually have no animals in it. But anyway, I had a friend of mine draw me a design inside of Revit. And so I've queued this up ahead of time. But for today's purpose, I wanted just to look at the outside shell, because ultimately I might take that into a GIS so I can kind of do some analysis of the neighborhood, or maybe I'm going to pop it into SketchUp as a stepping stone to get to other things. And so I want to go, actually today I will go to SketchUp, but I am going to go and read only the exterior shell. I don't care about the interior details at all of the barn, because I just want the outside for my purposes. So I've gone and set that. I'm going to say OK, and boom, it gives me a list here of the various categories inside of Revit that I'm going to pick. I'm going to say yes, I'm going to want all of them. And why was that so fast? Those of you that know FME's Revit Reader will know that it is a little bit slow. Actually, this Revit file is in Revit 2017, so it's got to convert that to Revit 2020. How did I get it to work so fast? As soon as you've read the file with a certain set of settings, FME actually caches the settings or the data that would come out. And so it's there for you again very, very quickly the next time. So you can also prime that cache, if you know, by running things overnight if you're working with lots of Revit files, and then it will be much faster once you work with it. So anyway, this is my whole exterior shell. I'm going to turn on feature caching, which means at each step I can watch what's going on in my translation. If I run this, there we can see the whole thing. And if I go, you can probably see, oh, I don't have all of them here selected, so I'm missing the walls or something. Yeah, the walls aren't turned on. So there would be the walls. And I can actually go and view my, my barn here. But what I wanted to do was go to SketchUp today. So I'm going to add a writer for SketchUp. And I'm going to just say SketchUp, which is from Trimble. I'm going to call it, I'm going to put it in this folder here. I say I have one there called barn. I'm not going to use that as my name ultimately. The way SketchUp works, it wants a folder where it wants to write files into. And then I have to go ahead and say that I want to make a file that I'll define myself, and I'll call it barn1. That's a very unique name for a file. And there it is. So now what I really am left with is I want to connect this input data to that one. And I'm going to use a little known feature of FME. There's something here in the windows called the feature type connections window. And I can ask for that, select all the inputs, select the outputs, and go kaboom. And wow. There it is. Yeah, hey, is that
amazing.
Andrea?
Yeah, holy, I don't think I've ever seen that.
Yeah, isn't that amazing? Yeah, it's a bit of functionality we designed probably in the year 2002 that almost nobody knows about. So that's today's find. But I mean, how would you have, even you've been at SAFE quite a while, how would you have dealt with this situation, Andrea?
I would have selected all of the feature types and then just probably put down a junction, because if I have them selected, then it will auto connect it to, say, that transformer.
Whoa, really? Okay, I'm going to disconnect all. I can disconnect them using this fancy tool. I'll get rid of this window just for good measure. Now you think if I go and select all these, there they're all selected. And if I just type on the canvas the word junction.
Yep.
Kaboom. Oh, wow. That's no wonder you didn't need to use my fancy window. Okay. Wow. Okay. So we both learned something this morning. So actually, I'm curious in the questions there, let us know if you knew either of these tricks if you're an FME user, because I'm wondering how well known these things are. And we'll find that interesting to pan through. So anyway, now I'm going to run this. And my gracious, is it ever fast to write SketchUp? It almost feels like it couldn't have worked. Let's take a peek in my file explorer. Yes, there's a barn 1 there. It's 720K. And yesterday I taught myself how to use SketchUp on the web. So let's see if we can do that. So here it is. It's pretty amazing. You just need basically a Google account. You get in here. I'm going to open the SketchUp file from my computer. I'm going to do barn 1, which I've never done before. And I get in here, and of course I can't see anything. So for the folks at home, typing Shift-Z brings you into here, and typing the letter O gets you into orbit mode. And we can tip it up, and here's the thing. Boy, it looks fairly barren inside there. I can see right through the other side. If I tip it all the way up and look inside the box, there's nothing there. So I did succeed in getting the empty shell. And so I think that that is the end of my part of today's presentation. I'm going to hand it off to Dave and Andrea to walk us through some more real examples that get a little more deep and have more than 0 or 1 transformers, depending if you count junction as one. So who's up next?
Awesome. I'm heading up. I'm just getting my screen ready. Hopefully you guys can see the slide there.
We can.
Yeah, thanks, Dale. Awesome. Thanks, Dale, for that little intro there for going and taking the exterior shell. I'm going to show how we can create an enriched floor plan from our Revit file. So we want to keep all of our BIM properties with our floor plan information. That's our goal. Now, Revit's native export to DWG for a floor plan does not include the BIM properties. So what FME can do here is we can read in just a 2D floor plan and keep those BIM properties so that we can produce enriched floor plan view. I'm going to show you how you can set that up in FME. And so here I have my workspace set up. And I have my Revit Reader feature types coming in already, and we're writing to Autodesk Map 3D so that this will keep our attribute data from our source data, and we're writing it to the Map 3D DWG file. For the Revit parameters, we saw Dale earlier only read in the exterior shells. Well, for this, we're going to read in all the elements. But one thing that's different is we're reading our geometry as floor plans. You can see there's a few different options here. So if you wanted to read in non-spatial, you could do that. But for our purpose, because we're only reading in, we only want a floor plan, we choose floor plan. Now this enables us to specify a view. So we can get a list of these floor plans that are in the Revit file, and we can select the floor plan that we want. So for this, we're choosing the second floor. And the other parameter that I'll just highlight here too is the one that Dale was talking about with persistent cache. So it's under the advanced section, and you can change how long that cache is kept for, and by default we set it to 14 days. So again, allowing you to work with those Revit models a little bit easier. So it will cache the parameters that you have set here. So if you need to change different parameters, it will need to create another cache. So if I go ahead and run this, we'll then take a quick peek at our Revit Reader, and then we'll go and take a look at our Autodesk, our DWG file in Autodesk as well. So just taking a look at these guys here, we can see that we are getting our floor plan view coming in from Revit in FME. And we can see there's also a number of different attributes that are coming in. So if we were to look specifically at, say, the doors, we can see there is also a door schedule that's being read, which includes, say, a fire rating. So there's a door here that has a schedule coming in, which we are reading in and attaching to that object. And so we'll be retaining that information as well when we're going to that DWG file. So just to show, this was written just this morning at 8:15. And if we go into Autodesk and we open up that floor plan, we'll be able to see we now have the floor plan in Autodesk. And if I go and select that door, we can see we have object data on the door feature, including the fire rating, that door number, and any other information. And again, I just dumped out all of the attributes that we were getting from Revit and into the DWG. So you could customize this and rename your attributes if you'd like them to be renamed to something else. So that's how you can go from Revit to Autodesk. And I'm gonna flip this over to Dave now to get into some georeferencing.
Okay. Let's see, show my screen. There we go. Geo-referencing the Revit data. Yeah, I touched on this a bit last webinar, but I want to go into more of a full demo here. So what I have is I'm using as a test data set a Revit model of a house that actually exists now in real life, which is good. So we can test that our georeferencing ends up in the right place. I wanted to start with the basics of georeferencing of the Revit data. And if we open up the Revit data parameters, the Revit Reader parameters, we can see that one parameter we haven't touched on before is the Revit coordinate system to read. We have a choice between project or georeferenced. And if you choose georeferenced, what FME will do is try to extract as much georeferencing information out of the file as we can. So if the survey point has been set, if the true north has been adjusted, all that stuff, we'll get as much as we can. So in this case, no coordinate system has been set on this data, but they have adjusted it for true north. So if we look at the georeferenced output, we'll see that this is the alignment of the building, which matches the alignment when we do north up to Google Earth, almost bang on. So we've got the rotation set up here, but we don't, if we sort of look at the coordinates in the lower right there, we'll see that, look down here, we'll see that that's still in the local coordinate system. So those aren't the most useful coordinates. We still have to adjust that to fit the real world. If we go to the project, then we're just reading the basic project display, the same way you would see it in Revit. Oops, not that one. The same way you would see it in Revit. So in that case, our output is going to look more like this. So they've set the baseline to the largest part of the house, and it's not sort of aligned to the real world at all. Okay, so now I covered one of the basic ways we can sort of georeference this ourselves as part of our transformation. And the easiest method, if you have the information, and you sort of get this information from a surveyor, is we would have a reference point location in the Revit file with the Revit coordinates. We'd also have the latitude and longitude of that reference point, and also the rotation from true north. And using that information, we can use a series of transformers. Let me just turn these on here. And that's just a combination of offsetter to offset our reference point to 0, 0, a rotator to rotate to true north, and then a local coordinate system setter. And what this does is it creates a local coordinate system based on that lat long point. And so we're still in that sort of the local coordinates, but we now have referenced those local coordinates to the real world. And we have a true coordinate system, and from this point we can sort of go and reproject to any other coordinate system that FME supports. But say you don't have this information from the surveyor. Well, we can always try to get a sort of a rough estimate from Google Earth. And if your building already exists, like this one does, we can go into Google Earth and we can place a place mark. Just usually grab a building corner that you can see. Now, normally I like to find a building corner at ground level because then the building lean doesn't come into it. Unfortunately, with this house, it's local Vancouver area where it rains a lot and has really wide roof overhangs so your walls don't leak. So we're going to have to pick, just for illustration purposes, a roof corner here. So if we we place the place mark, and I'll show you how that's done. Just click there. New place mark. We move it into place. This isn't too convenient. I like to change the icon a bit to something that's kind of circular, so then I can see where, that we're actually getting it on the corner. So we get on the corner there. There we go. Go OK. And then you see here we've got our latitude and longitude of that corner. And then we can kick that into the latitude and longitude of the parameters here. We can also look for that same corner check. Okay, that's that one. If we bring up our data that we read in the project coordinate systems, and if we look at the feature information window here and we scroll down, we'll see what we have the coordinates here. And if you click on a coordinate, it highlights the dot where it is. So all we need to do, let's zoom this in a bit, you can see a bit better, is we go through and we look for that outside corner. Okay, there we go. So number 12. So what we can do is right click on here and just go copy that text. And then we go back to the workspace. When we enter the ref Y, we can just Control V and add that in, get rid of the coordinates we don't want. And the same thing with the reference point Y. Projection units, generally we know what's in our file, whether it's feet, meters, or millimeters. And now for the rotation angle. So we can also get that from Google Earth using the measurement tool up here. So we scroll that out of the way. And if we sort of pick a line, we can sort of draw it out. You want to follow the baseline of the house. And if we look at the window over here, it gives us a heading. Now notice it says heading. And that's the difference between Google Earth's angle and FME's angle. FME is working with Cartesian angles, so we're measuring counterclockwise from horizontal, whereas Google is measuring clockwise from vertical. So in that case, you probably want to measure your vertical angle. So let's try, let's just grab this angle here. So that would be the vertical angle corresponding to the vertical line here. And if we look at that, it says 331.63 degrees. That's okay. So that's the angle. That's the angle off of the vertical, which in our case is also we can use for the angle off the horizontal. But we're going in a different direction. So what we want to do is make that a negative. Put a negative on that when we go into FME. So we have negative 331.29. So if we run this quickly and see what our results are, now we populated all this stuff. We'll click the output at local coordinate system setter. So we see that it's aligned it all into place. And it's put in its own coordinate system, but we're going to turn on the background maps and just to see if we've sort of got it in the right location. Okay, map data not available. Let's scroll out a bit till we get a scale that can handle. There we go. So we seem to have put it inside the lot correctly. They've got the outline of the old house. This is a new construction, is still there. But we see the property line, the surrounding houses. If we switch back to Google Earth, you can see we nailed it pretty good. Now again, this is kind of a rough estimate. And like I said, you'd be better off if you could get the surveyor information. Now we can sort of refine this a bit because this heading is only to 2 decimal places and you're only using 1 place mark. And there's probably another way that we can be a bit more accurate. And that way is we're going to try using, instead of a single point and angle, we're trying to grab a bunch of points here. Let me just zoom out and enable this part. So what we're going to do is use multiple points and calculate it in a fine transformation to fit that into place. So the way you do that in Google Earth is you see I have several place marks placed here already. And I'll just place one more to show you how it's done. So we have our place marks here. I'm going to put one more place mark in. We're going to again change, not saving this for me. Okay. Now we're going to move it to that corner again. Okay. But this time as well, we're going to take that coordinate we got from, we copied in from here. So let's click that again. That's 12. Okay, we're going to copy that text. And we're going to go into Google Earth and we're going to paste that into the description link right here. So now we have the lat long coordinates and we have the local coordinates. And all of these place marks have both of these pieces of information. So then we're going to take this these place marks and we're going to save those as a registration file, a KMZ file. So basically, going to save these out in the Google Earth format. And luckily, this is the format we can read in FME. So we're going to bring these in. I'm going to run this quickly so I can walk you through it. Oh, and this is the other thing I'm using, and we've had this for a few versions now, but it's known by default, and it's the enable feature caching mode. And this is really nice when you're setting up a workspace. When you run a feature caching mode, what we do is we save a copy of the data as it goes through each transformer, and that way you can look at the data as it goes along quickly and see exactly what you're looking at each step. It takes a little longer to run, but it's useful when you're building your workspaces. The only time I wouldn't recommend using it is if you're working with rasters, because raster data takes a long time to write to disk. And we've jumped through a lot of hoops here at FME to try to avoid that as much as possible. And once you enable feature caching, that all goes out the window when we have to write each step to disk. So don't use it with rasters. So if we look at our points here, the input from Google Earth, we have our point data. It's got the lat long, and it's got our points in the description. Cool, we've got that so far. Next thing we want to do is force the points to 2D. We don't need the 3D. We don't need 3D data. The next step after that is the common local reprojector. And what that does is it takes those lat long points, calculates the best local coordinate system that fits all those points and creates that. And the reason I do that is because lat long coordinates are spherical, so they're not on a flat surface. And things like your longitude, the size of your longitude changes as you go from different latitudes. So the transformation between that and a projected coordinate system, which is what we want to work with, is not something that can be done by an affine transformation. So we're using the power of our reprojection engine to put those now in a local coordinate system that's being given basically the name of the common local point that it's moved to. So again, this is a coordinate system that once the points are in here, it can be reprojected to any other coordinate system in FME, but it is a true projected Cartesian coordinate system that we can now do an affine transformation of our Revit data into. We use an attribute splitter to extract the data from the Revit points from that description. We use a vertex creator to create to add a point to those the input points to create control vectors. These are lines that go from one set of coordinates to the other set of coordinates. In this case, because of the way we created them, they're going the wrong way. So we use an orienter to flip them around. And then we use a transformer called the affine warper. And what this does is it takes those control vectors and it calculates the best affine transformation to go from the first vertices on those lines to the second vertices on those lines. And once it does that, we apply that to the footprints to actually move that into place. So if we look through here, we'll notice that our Revit data has been aligned into position and moved into position. But if we click on it, it still doesn't have the coordinate system. And that's because the affine warper doesn't actually transfer the coordinate system over, it just moves the data. So we have a second set of transformers that extract that coordinate system, merge the coordinate system on, and this is using what we call an unconditional merge. Normally a feature merger requires a key field that has to match between the two, but quite frankly, if you just hit 1 and 1, this says just merge it all. We don't care about the keys at all, just go for it. And once we do that, we've merged on the coordinate system name, and then we use the coordinate system setter to set that name on the data as its true coordinate system. Now if we click, we see it has a coordinate system, and again, it's ready to reproject. And if we look at this, now that it's in its corrected stage, we bring up our topo map again, zoom out to where we can see things, and lo and behold, it is in the right spot again. So that was just basics of ways to georeference. And again, the preference is that if you have survey information, use it. These sort of do-it-yourself methods are kind of good if you're in a GIS type environment and you don't have to be narrowed down to the nearest centimeter or anything. These should be pretty good to the nearest meter. So. Okay. Let's answer a couple of questions.
Nice, thanks,
Yeah.
Dave. Oh, go ahead, Andrea.
Oh, I was already going to ask Dave a couple of questions up here. Someone's asking, how will the geometry change after using the affine warper? Does the area change?
It may change. It shouldn't change too much because the coordinate system we created is local to those points that we chose in Google Earth, which are local to the model itself. So that we're basically going from one local coordinate system to another local coordinate system, and we're not actually moving. We might be scaling a bit if we're changing the, if we're coming in in feet and we're going to meters, say, that will scale up those values and it will scale up the data. But again, it's from a very local coordinate system to a very similar local coordinate system in this case. So it really shouldn't change things that much.
Okay.
While we're on the topic of coordinate systems, Dave, maybe you can say a few words about how do we georeference IFC, because we don't have quite full coordinate system support there, but you can set some of the IFC parameters that help you georeference, correct?
Yeah, the IFC is georeferenced the way some of our other systems like the SketchUp are georeferenced, and in a way, a little bit like we have for Revit, in that IFC is assumed to be aligned to true north, and most IFC exporters, will adjust yourself to true north. The other thing is it has in there a lat long reference point in IFC to the 0, point of the IFC coordinates. So again, you're getting, your rotation 0, you're getting a known point, and you're getting a known unit. So then we create again a local coordinate system based on that lat long point, which again can be read or can be reprojected within FME to any other coordinate system you want. This also applies to SketchUp as well. If you set the reference point lat long in SketchUp, we will do the same thing.
Yeah, another quick coordinate system question was that coordinate system that FME generates from the common local reprojector. Can that be saved to be used elsewhere later on, or you'd have to kind of retrieve the parameters and define a custom coordinate system? You
could. Well, the neat thing is its parameters are actually saved in its name. So we give this huge long name, but essentially if we're saying it's an azimuthal equal distance coordinate system, its datum is WGS84, its origin is latitude -122, etc. Its longitude is -49. So actually at the point here where we extract the coordinate system from the data, we could actually kick out a text file here just to write that attribute out to a text file or a sidecar file. If you wanted to, we could actually even generate possibly a PRJ file and write that, the Esri description, write that out to a PRJ file. So there's a bunch of different options you can use to save that information. But ultimately, all the information you need to know about it is in that name. So if you just save that name out as a piece of text, we could then turn again at another point, parse that name, and create a local, using local coordinate system setter. Again, we could parse that name out and then put the origin X, Y, Z, or the X and Y are in that name, and then we could generate that coordinate system all over again for you.
Okay, great. Yeah, thanks.
Okay.
Awesome. I think that's probably good for questions. We do have a couple more demos to do, but we have more time at the end for questions. So I think, Dave, why don't you go forward with the other demos, and then we'll get back to some of the questions later.
Sure. In the last webinar, we did a sort of quick material takeoff of windows and such, and we were asked the question, how can we do like a more real world material takeoff? So I thought I'd give that a shot and get as real worldy as I can, not be an architect. And oops, sort out my screens there. So what I wanted to do is I wanted to take a building, and I wanted to calculate how much drywall or plasterboard would we need for that. So that's something that needs to be calculated. We can't just query that. We got to sort of look at our walls and see how our walls are built, and if it's got plasterboard on both sides, like an interior wall on one side, like an exterior wall. And let's see if we can sort of calculate that information. So I read the advanced sample project that comes from Revit in it's the Revit data, and we'll just take a quick look at it now. So I'm looking around for the information that where am I going to find that information on the plasterboard? Well, I click on a wall, and I can see that, yeah, it's a wall. It's in, here we go, family type interior. We say how width it is, and it's got a 1 hour, and to me that's fire rating. It says it's an interior wall, but you know, it doesn't really say anything about the composition. And it's got the height, so we could sort of work out the height and the width and sort of subtract any openings and stuff. But you know, the key thing is we don't know what this wall is made of. But I remember when I was working on IFC data that it would give you that sort of information. So I figured let's have a look at IFC instead. And if we go to Revit, Revit has an IFC exporter. So if you go File, Export, you can export out to IFC. There's a bunch of settings in here that you can change, but the key one for our purposes is it has a thing of property sets, and for some reason these aren't all automatically checked. And my rule of thumb is find out everything you can. So let's ask for all the property sets. With Revit, common, base quantity, everything. We want to know everything about this data. And I exported it out to IFC file. So now if I look at the IFC input, in this case, I took the walls and the wall standard case, and I'm quite frankly not sure what the difference between them is or why they have two completely different feature types, but grab them both just to be sure. And I just take a look at the walls. And we have the wall data here. Oh, let's turn off the background map so speed things up a bit. And again, we have some attributes here, but in IFC, because IFC is a hierarchical format, so it's kind of like one big tree. So to make sure that all of the attributes are stored correctly, what we do is we store them as parts of the tree. So in IFC, a lot of the information you want the property sets are here as part of the geometry. So we have a geometry definition of null, and we have a trait on the geometry with the information, and we also have the name of the property set. So we have the name of the property set and property itself. Well, that's not really that useful for working with this stuff. So the first thing I do, I throw it through this geometry property extractor, and what that is that grabs all of, I mean, you could put in individual traits you want to extract, but if you leave it blank, it grabs everything. So I said, grab all the traits, let's promote them all the way up to attributes so I can use these things. And at the same time, let's prefix each of those traits, each of those properties with the geometry name, and that's going to be the property set name, because otherwise we don't know what's part of what geometry set or what property set. So if we look at the results of that, and then we click on a wall, David hasn't had his coffee this morning. Okay, so now, whoa, we've got a lot of information to work with. So after diving into this information a bit, I found that, what do we got? So we got materials and finishes, structural material layers. Here we go, materials. We got a list of materials names here that sort of give us an insight, from one side to the other side of what this wall is made of. So we've got plasterboard on one side, makes sense. It's an inside wall, metal stud layer, okay. Plasterboard on the other side, and plasterboard again. oh, that's kind of weird. Why do you have 2 layers of drywall? So, but then I looked at the identity data, and so 130 millimeter partition says 1 hour fire rating. So, okay. So they've thrown an extra layer of plasterboard on there to increase the fire rating, which makes sense. But again, this is something, you know, not necessarily, we weren't actually getting from the Revit file. And I think the reason for that is, I believe Revit stores a lot of this type of information, not in the RVT file itself, but in the family files. And this is something we're probably going to have to look into going forward in our Revit development, is we need to be able to access probably these family files as well in some respects, because the RVT file just doesn't contain all the information. And you know, RVTs are meant to go from Revit user to Revit user to Revit user, assuming they all has the same family files. So we need some way of figuring out how to get that information out, which we'll be working on going forward. And then meanwhile, we know we can get it out through IFC. When Revit puts the IFC, it merges all that family information in. So we see we have 3 layers of plasterboard, and we also have a thickness layer here, which is kind of cool. So 15.5, 15.5, 15.5. So we're going to grab the material name. We're also going to grab this layer thickness, because that's kind of useful to know if you want to know what sort of size of drywall you should be ordering. Now, we could measure the area, but if we look up under some of the other attributes, we notice we have this here, base quantities, gross side area. And I looked into that a bit. I found that while it says it's gross side area, it's actually kind of its net area, because they've already taken openings for windows and doors out of that. So that's actually the measurement we want to use, because we want to use the drywall that's actually used. So we know what information we're looking for now. Now we just have to get that out. Oops, wrong one. There we go. So we've extracted the geometry property. Now that I've gotten the properties of geometry, I really don't need the geometry anymore. So I find a geometry remover. And the reason I do this is that IFC doesn't actually implement the geometry until FME needs it for something. And it's a CSG geometry, and it's a little expensive to implement. So by getting rid of the geometry that we don't need, it gets a lot faster, because we don't have to do that creation of the geometry. We're going to explode that material list and get that material in the thickness list as well. And then we're going to use an aggregator, and we're going to sum by material. So we're going to join by material layer, thickness, area unit length, and length, area unit and length unit, to make sure everything is on the same page. And now we're just basically, this is doing our calculations. So we're summing the base quantities, gross side area for each of these categories. And do a little string formatting, and then we can see what our output is we have a simple table of all the different parts of the wall. So we have type, we have plasterboard here. We have 13 millimeter and 15.5 millimeter. So that's what, 1/2 inch and 5/8 inch, I think. And then we have the area, square meters, the area needed. There's still some more calculations to do from that. Obviously, there's always wastage. You want to add 20% or so, and you want to put that into square feet and divide that into sheets. The other thing we probably should have done, well, you know, there's also plasterboard on the ceiling as well. We could add ceilings in as well to this calculation. But that just shows you a pretty simple, you know, material takeoff, but in a real world example, and how we have to sort of dig down sometimes to look at the data. Okay. So any quick questions there at all?
There were a couple of questions around, you know, using FME to generate, let's say, a floor plan, or actually like a user manual for architectural user manual from let's say a Revit file. So basically, read a Revit file and pull out a bunch of different floor plans and write that to PDF on different pages. So I mean, that would probably take a bit of setup, but in theory, is that sort of thing doable?
Yeah, not using and actually that would be a good part for the Andrea's demonstration there, where you get a very a nice looking floor plan from the using the floor plan views.
Right, and then you can write those. You can read basically all the available floor plans and write them out either to different pages or even different documents.
Possibly. I'm not that familiar with the PDF writer to know what can be done, but I think you can set up different pages and such.
Yeah.
And there's also a non-spatial mode, at least for the Revit Reader, to you know, extract any extra metadata information. Those were a couple of feature types that I was not reading in earlier. So you could certainly get some of that metadata information into some owner manual as well.
Yeah, and cool that we're talking about metadata, because that comes into my next demo. And just moving along here because we're getting a little short on time. Now, the purpose of this demo is we want to read the Revit file and we want to go to a GIS app. So we want to simplify the data. We want to go from 3D to well, we want to get output a 2D, like a floor plan view. We want to simplify it a bit. We want to put it into the ArcGIS Indoors format, which is ArcGIS's new sort of indoor database. So I thought I would show you some of what we do there. Now, we're going to read in from the Revit data the rooms and the walls. That's what we really need for this. This is going to be a fairly simplified representation. But rather than using the 2D views like Andrea showed you before, the floor plan views, those floor plan views, they create a good looking product in that it looks a lot like the Revit view when you look at it. But to do that, it does something that's called occluding. So it sort of cuts out some pieces with other pieces, and that makes things look good. But what I'm looking for is pure polygons. Now I could go in and create my own view within Revit that just has the rooms and the walls and nothing else, and that would give me what I want. And I don't want, because I don't want all the other things like electrical fixtures and stuff clipping out my walls. But it's easier if I just grab the 3D data and squish it down to 2D, because it's fairly simple and there's not too much more. So I grab my rooms, I grab my walls, and I use this surface footprint replacer. This is a really nice tool, and it basically takes any 3D object and creates a 2D output. So if I click on this, I see that I've got 2D polygons now of all my rooms, but they still have all the information attached. So that's cool. So that's a good starting point. But the problem I have is I want to actually build up the floor plans by building level. So now I need to grab the walls that are on one level and then the walls that are another level and divide them out. The problem is Revit's not really built that way. You'll have a wall that spans several building levels, and even though if I look at the building level here, there we go. Building level, say this is on 3rd floor, okay? But it might be a wall might have its base on the 1st floor and go all the way up to the 3rd floor. So I'm going to need a copy of that wall on each of the floors that it exists on. So I'm just going to go over this very briefly. I won't go into too much detail, but the metadata information you can read from Revit contains all of the building levels and their Z ranges. So I take that information and I get the Z range from each building level, and I build up a table that I'm going to then use. I attach to each of these features coming in, and then as a list. So there's going to be a list with each level in its as an element in that list. I explode the list. So basically, I'm creating a copy of each wall for each level, and then I'm going to look at the range of that wall and see if it fits within the range for that building level. And if it does, I'm going to keep them. So if a wall is on the 1st floor and the 2nd floor and the 3rd floor, I'm going to keep each copy of it to go out to my GIS. And remember, we've already made these things 2D, so it's basically going to get a 2D polygon of that wall on each of the levels we want to. The other thing I'm going to do, and again, I won't go into this huge detail, is I have a simplification procedure, and I'll share this workspace afterwards. And what we're going to do is we're going to take, if we look at the walls here, we'll see that, we've got wall parts here. And if we look at the rooms, we'll notice there's gaps in the rooms as well, where the walls fit. And this is not really what we want. We want a seamless coverage. So I could make the walls into little rooms, but that usually doesn't make anybody very happy. So I've just got a process here that sort of takes the center line of the walls and blows up the polygons and uses the center line of the walls and sort of expands the polygons to fit those set of lines, and essentially simplifies the wall. So you get, oops, that's not right one sec. So you see that here, if we zoom in, that the walls have all been simplified and most of the gaps have gone away, except for this one where it's a fairly big structural object. And so that's sort of the sort of thing we're looking for. And then just a little bit of cleaning up and output to the indoors database. Now at this point, we only have rooms. So what I do is the rooms go out to the units. The rooms essentially get dissolved and merged by floor to create each level. And then all the floors get merged together to create the building. And then we just take the building and throw a buffer around it to make a sort of site polygon. Now, if we had the site information, like a property line information, we would probably use that there. And the result we get, if we look in ArcGIS, is we now have a nice indoor model with no gaps in it, and all of the information that we want about those rooms and everything has been taken over from Revit. So that kind of winds up this demo. Like I said, this was just kind of a quick overview of it. We'll share this workspace, and I've annotated it for clarity if you want to use some of those techniques. But I just wanted to show mostly that the metadata information is quite useful in Revit sometimes, and an alternative method to producing the 2D view. And at that, I'll turn it back over to Dale.
Wow, thanks, Dave. So let's see, we got 6 minutes left, and I guess we'll highlight some of the resources. Actually, tomorrow morning, we're going to be right back at it with a panel about spatial data integration. And I can't remember do you know who's going to be on that one, Stephanie or Dave?
Yeah,
I'm on.
Yeah, Dave's going to be back on, and you're going to be back on. And then we have Dawn and Mark Stokes, and we have Mark Ireland on Q&A, and Dan I always mess up his last name, but we have Dan on Q&A as well. So it's a really great team of experts, and I think you guys did the math for me, and it was like over 100 years worth of spatial data integration experience.
Well, thanks for that, Stephanie. As Indiana Jones says, it's not the years, it's the mileage.
Exactly. No, it'll be a great one. I'm going to chat up the link.
Yes. And we'll spend a few minutes here in a few seconds looking through the great questions. I got to say, thanks so much, audience, for keeping us going. And I know there's going to be a few follow-up calls we're going to be making as well. So, Dave, you want to just advance to the next slide?
Sure thing.
Oh, even more resources. Dave, I know you love Excel, don't you?
Oh, I love it so much.
So yeah, Kobe is a thing, and I'm guessing, did you or did Dean write that article that's linked there?
Both of those are mine.
Okay, yeah. And AutoCAD to IFC. We had a lot of people asking about IFC and FME. Dave, there was a question around the many different flavors of IFC. Do we write, which ones? There's an XML encoding and the old step encoding. Do you know what we read and write out of those combinations?
Okay, we can read both step and IFC. Presently, we can only write the step.
Right, so we don't write the XML one.
Yeah, sorry, XML, we don't write XML. So yeah, step and XML we read, but step only for writing.
Okay, and I was hinting to the audience there that we are considering moving our IFC support to using some libraries from an outfit called the Open Design Alliance, who are committed to IFC. We are longtime members of the ODA, going back more than 20 years, I think, or at least since their very founding, and even before they were founded, some of the founding technology we used in FME. And so anyway, they've got a fairly comprehensive commitment to IFC, and we're thinking of that. And so I would invite anybody for whom IFC is important, please chat to us now. And when we undertake that project, we would want to be talking to you about your exact needs on both IFC, import and export. So do chat to us if IFC is important. I also had some folks asking about the old Revit exporter, the plugin that we used to have that would produce a zip file, which was basically a glorified, enriched IFC. In the beginning days, the IFC was supplemented with some CSV files that we would dump. But Dave, I think you were the one that kind of pointed out that was largely no better than just IFC directly. Is that fair to say?
Yeah, pretty much. However, we did keep some of the work we did, and when we created that sort of initial Revit Reader, we created these things called data views, which was kind of a few different ways you could read the data. And I showed you before how that IFC geometry was very complex. And these are just some data. It's like a view that we simplify that geometry so we can automatically create a building envelope or a floor plan or spaces or elements. And the stuff where we extract the data out of the geometry is all done automatically for you. That does still exist, as it's just renamed now to the IFC with Data Views Reader.
Okay, and so that's what works on any IFC file.
That works on any IFC file. Yeah.
Excellent, excellent. Yeah, great. So yeah, and we also have some other BIM tutorials. This is fairly intense stuff, but Dave, if you were going to give folks advice on how they could basically boot up on BIM and FME, I guess those articles you listed there, you'd say go through all those. Is there any other materials you'd suggest? The tutorials, I guess.
There are some other IFC tutorials. We have a couple of webinars that are worth watching.
Yeah.
There's some of my older ones. Yeah, go through there. Some of them are more step by step today, or they cover different areas. But yeah, the BIM webinars up until a couple of years ago are pretty much IFC, only IFC, and
Right.
they're all still available. And as well as our support team is always happy to help you out if you run into any particular snags.
Yes, I know. Before I forget, I just wanted to mention, because it did come up in the chat, for others might find it useful. The idea of batch exporting from Revit. Of course, the FME Revit Reader can do a lot of stuff in batch, but if you want to use Revit in batch, when we had that old plugin, we did an alliance with these folks out of New Zealand called RTV Tools. So if you search for RTV, and that was a play on RVT, but anyway, RTV Tools, they have a Revit Exporter Pro that can do batch exports from Revit in a headless way. If you want to dump all your stuff to IFC while you're sleeping, that probably is a cost-effective way to do that. So anyway, I'll take the next slide because we're almost out of time here. And that is just to remind folks that if you want to get going with FME, we have very attractive subscription options for all kinds of organizations. It's a cost-effective way to get started, or you can buy licenses from us. And you can also run our stuff in the cloud, and that's on the server side of things, which we didn't actually touch on today at all. But all the stuff that Dave showed can be posted up and run headlessly while you're sleeping in the cloud. So we'll take the next slide. And that's it. We'll thank everybody. My clock says 9, so we did finish on time. And Stephanie, it didn't cut us off, but we will hang around and answer more questions. So let's bring the whole panel on. And does anybody have other things that you wanted to address?
Sure. I'm super happy it didn't cut us off.
Yes. So yeah, anything else that on the questions and answers we should be talking about?
One thing I'll just mention, I think I chatted this out earlier, is we will be sharing our workspaces with a recording of the webinar too. So in case you want to review some of Dave's workspaces there, we'll
yeah, and I also have a Revit to Apple's indoor mapping workspace, and it's very similar in structure to the Esri indoor. So I'll share that one as well for those who are interested.
Yeah, there were some questions about yeah, Revit to IMDF, so that would be good.
Yeah. That was actually when I was thinking of doing the demo, then I thought I'd go, no, I'd go a little bit more generic and probably should have gone the other way. But anyway, they're very similar.
Yeah, and now IMDF is actually a candidate standard for at the OGC, so it's not necessarily just for Apple use.
Yeah.
I'll also just take this time to see if we can recruit some folks that might want to help us figure out what we should do around Navisworks and FME. We have access to a library for reading and writing Navisworks. Don't know too much about that product personally, but others at SAFE do. But if that would be of interest, let us know. And I can advise, we just had a very good call with the Rhino people, and I can see a path forward for FME working with Rhino. And so again, if anybody on would want to use that, chime in and let us know, and we can follow up with you to make sure that we're hitting the mark when we undertake that. I can also see using that Rhino inside to do some high-end 3D processing using their technology that they've made very accessible to third parties like ourselves. So if there would be scenarios like that, please let us know too.
I'd also be curious from this audience, if for future demos or resources online, how many people are actually working with things like City GML, or are you predominantly IFC, Revit, and like Esri GIS? So if that's of interest or not. I did have one really quick question. This is a bit specific. Well, it was basically affine rotation is easy with vector, but not raster, because rotation in raster origin is upper left versus bottom left. So would that sort of affine method that you used earlier work for raster, or it's only for vector?
It would work for raster if you are just cognizant of your coordinates. So your base point would be, the upper left, and then you just have to make sure that your coordinates go downwards in both cases. I would have to actually, now I think I'd probably have to, but there's definitely a way to making it work.
Yeah, there's a transformation matrix that's part of the rasters that it feels like we could tack on. I don't know if the affine does that. I actually haven't tried, but isn't that the case? That there's some raster folks on this webinar from SAFE that rasters can have a transformation matrix, which then presumably our affine would just slap on it and it would just do the right thing.
Yeah, and ultimately to work with it, I mean, worst comes to worst, you could just grab a bounding box replacer of your raster, run it through the affine transformation, and then use that the coordinates from that bounding box to just geo-reference your raster.
Right, or that, or a raster properties extractor might get you the information you need.
Yeah. But this way, but if you get the vector polygon, then you're working in your standard, Y is up space, and then you don't have to worry about it.
Okay, good idea.
Some more love for the Revit exporter here about trying to have it process nested RFA. And I think that we could read RFA with our Revit reader, but I don't know if we can. Like that was, I know, bubbled around. Does anybody at SAFE know?
The native Revit reader, I don't believe we're reading those RFA files.
Not presently. I'm not sure whether the underlying library has the ability, but I don't think we've built it in yet.
I think the library does. So anyway, that would be something interesting to consider, and we may follow up with you, Andy, someday about that.
Yeah.
Okay.
I love all these. We got so many great questions. It was a lot of fun for us to get to interact with the audience this way. And hopefully some of you come back for the webinar tomorrow. We're actually going to offer, if anyone wants to come on the webinar tomorrow and chat with us on the air, that's going to be available too. So lots of fun things coming.
Right.
Maybe a quick question, Dale, before we go. There was a couple questions around things like arcs, and I know there are things like sweeping. You can have swept curves and things like that as well in Revit and IFC. So maybe a few comments about what geometries we do or don't support and where that might be going.
You know, I was reaching out to the geometry team this morning, but the person that knows the answer is on vacation. I don't know how complete or what happens. I know something will happen when you put all the different geometries through the affiner, but I don't know, you know, specifically if we stroke the arcs or, you know, what exactly we do. So I don't have an answer there, but we will figure that out maybe by tomorrow if you come back to the ask us anything, or if you leave it in the, if it is still in the questions and answers, the team does follow through on that, and we can try to figure that out. But yeah, I know I don't know if arcs, what happens, or if you have a 3D arc that's tilted when you put that through an affine, what goes on. I don't know.
And there was some questions here about IFC 4.3. I know that I think it's in 2021, we recently added support for at least beginning to support IFC 4.3. So adding in the feature types and everything. And then in that case, I think we do, when there's some new geometries there, we tend to stroke them if we don't yet support that type of curve.
Right. And so that is a big, we're kind of gearing up to look at FME's geometry model and expand it for more of these complex BIM geometries, so that we can do a better job of round tripping and so on. So I know swept curves are being looked at right now. I mean, some of that is so we can better support FME AR, augmented reality, coming out of these things, because if you can handle swept curves and we can have formats that deal with that, it's much faster end to end. So that's one of the things there.
And the other big picture side of that is just around, you know, it's one thing to go from BIM to GIS, and you know, in terms of a high level workflow, but going from GIS back to BIM presents, or round tripping for like updates, that presents certain challenges if you're doing stroking and whatnot. So I think that's another emphasis that we're seeing, is more use cases and more emphasis around doing a better job when we write to IFC or Revit, correct?
Yeah, we don't write to Revit yet, but I think that's sort of a frontier. There was this idea years ago of writing a slim BIM. So you're starting with, you know, GISC kinds of stuff, and bang, you can go and make yourself a starting point inside of Revit. And that's still a dream of ours to get there. If writing to Revit would be of interest, please chime in here as well. This is kind of like a focus group now that can tell us things. I do see people chiming in, excited about Navisworks. To be very clear, it is not available in FME now. But we have been part of a consortium that, so we have access to libraries for it. We just haven't actually done it yet. But
when it comes to writing data into Revit, there is a Dynamo plugin that uses FME to import data into Revit that I put together. Early stages, it's written in Python. It's not super fast, and I would say right now I would recommend it only for tabular data import. Say, because Dynamo only reads from CSV and Excel, but if you'll need to read from SQL Server or Oracle or any sort of tabular data, that will work quite well. The geometry, I would say, is kind of iffy.
All right.
Cool. We had someone asking too where the best place is to ask for these ideas or requests, and definitely the FME community. We have an ideas page there, and people get to vote on your idea, which brings a little bit higher in the list maybe. So definitely check out the FME community and ask for ideas there. But
yeah, we definitely regularly review what goes into those ideas. So that's not just, you know, internally within the community, but that feeds directly into development. We see what people are interested in, and that helps us prioritize.
Totally. I think a lot of the time our users don't realize how much power they actually have over FME. Like, we really take their ideas into consideration. So we love it when you guys share. But I think with that, seeing as a lot of us are back tomorrow, we can probably take this offline and then talk to you guys tomorrow as well. But do let us know in the follow-up survey as well what you guys thought of this BIM series, because it was a lot of fun for us, and we hope you enjoyed it, and we would like to do more of these kind of series. So let us know what you thought, if you found it valuable. We'd love to hear it. Cool. Great job, you guys, on the presentation today. It was a lot of fun. I think the people are going to find the recording really valuable as well. So good work.
Okay, thank you.
Cool.
So thanks,
All right.
everyone.
I'm going to close this down. I'll leave it running for a couple minutes, but we'll kill our webcams. And then if there's any last questions, you can type them in and we'll get to it. Thanks, guys.
Bye-bye.